sorry, I have to make another run, and I have to continue this video on a different clip. So this is perception part 2. Anyhow, continuing from where we left off, uh, there are forms of radiation and gravitational waves and many other phenomena in nature that our bodies are very ill-equipped to perceive them and even measure them. I think that this range continues. There are like psychic energies and waves, forms of perception that we are sometimes awakely aware that limits our physics and mathematics, because the physics and mathematics that we have constructed are based on perception and measuring these perceivable quantities, and if we are unable to perceive them, or everything is out of our range of our senses, we have more difficult time. We really have to build the specialized equipment to first of all intercept these energies or these waves, and then measure them and all that. And the other concept that's very valuable, and many people they do not go after this, is that the human consciousness is the same thing as the super consciousness of the universe. And if one becomes aware of his or her own consciousness, this consciousness can perceive the universe in ways that are not physical, because you will know things that are older memories of the universe. I mean, if I went into some of this stuff, I'm going to just sound like a complete nutcase. But some psychics, they call it Akashic records. The universe has memory of the past creatures, past events, and this memory is somehow infused into the fabric of universe, and if you tune into your own consciousness, you can perceive these memories. Okay, this right now sounds like total speculations, but hey, extending these ranges of energies and waves that we can perceive will help us discover many new things. In fact, I think that the future science and technology will be device driven. For example, I'll tell you an example. The Kepler mission, this mission has been able to identify thousands of extrasolar planets, because there's just it gazes at all these stars and sees variation of the luminosity or energies coming from the star, helps it to find planets. So that's a device. That's not the kind of science that we have. Our older form of science was based on inference, and it was extremely limited, because we had to first measure something that we could, with our apparatus, with our devices, we could measure it, like the luminosity. And then from that, we had to infer, using mathematics and statistics, some other phenomena that might exist. It was extremely limited. But say, for example, let's compare statistics with data mining. Okay, in data mining, you have a universe of data points, and you know everything about every data point, because it's already in the database of the computer. You already collected that. So if I want to make a curve showing the progression in certain variable, I could do it perfectly. I don't need statistics. And this is a new science. This is a device driven, because the device already collected all the data points. Okay, so what I'm saying is that as we get better telescopes, better information gathering, um, better memory, all that, everything will become like data mining. You just know everything about the data point because the machine or a telescope or device already collected that everything there is to know about every variable that can be measured with our devices. It already knows it. So there is no inference, there is no math, there is no you are not guessing, you are not using statistics, because you already know everything about it. Same with Kepler. Kepler looks at all these stars and records the variation in luminosity. Okay, if you say that these are all data points, okay, the device already collected almost everything about that data point over a given period of time. So what inference are you doing? There's nothing. It's just you are using algorithms to and devices to infer, but this inference is really as a result of algorithm and the device. I mean, you get the point if you study math or statistics a little bit. And the other point is that in this universe of data points is now massive. It's not like in the past you could you'd have sample sizes and say, for example, you wanted to find who's going to be a president, you would have to have 1,000 volunteers. Okay, that's a sample size, and this it wasn't very reliable because hey, you could have all your sample size from Southerners, and they have a certain slant in the political ideology. So your output would be skewed in a certain direction. Okay, and that's not the same with data mining. Instead of 1,000 people, you had 200 million data points. I mean, that's device-driven science, device-driven results. Okay. Our future sciences and technology will be extremely exotic because our devices are becoming extremely accurate and extremely they can measure stuff that it's unbelievable, and the data points are massive. What I think we should do in the future is build gravitational wave detectors and neutrino telescopes, because I am conjecturing that we could see what goes on inside the black hole if we had a neutrino telescope. Anyhow, that's just a conjecture. Or try to look beyond our universe. If these particles, they can go beyond the event horizons. I don't know if everything can, but that's they're so light and so they can go through anything, or maybe they can go through the event horizon. I don't know. Our senses and studying them is extremely valuable, and many mathematicians have studied this. In the 17th century, many mathematicians studied projective geometry, how to project a three-dimensional object into a 3 or 4 surfaces, and maybe we can do that with membranes, and this will give us a way of looking at our three-dimensional world and conjecturing or constructing these n-dimensional membranes that give rise to our physical universe. I think that our physical universe is a projection of an underlying reality, or underlying consciousness, that it projects itself into in this manner. Okay, and the, there are layers and layers of reality. You go down, there's more reality, and because every particle is connected to each other, this feels to be a certain form of consciousness or a decision tree. And another concept that's very interesting is the fact that the universe is non-local, and when the reductionist methods fail, you are stuck with the concept or idea that the whole universe is like one entity, and it's like one cell or one body. And well, this is a very interesting way of looking at reality. We are so used to cutting stuff into pieces and studying each piece separately. We are not used to looking at the whole thing and see maybe this is a better way to go. Anyhow, I hope I didn't give you a headache. These ideas are kind of far out, and we'll go over some new ideas I have at later lectures. Thank you.